Okay, great. So good afternoon, everyone, or good morning, depending on the time, on your specific time zone. And welcome to this webinar on chemical recycling, what's role for the EU's decarbonisation and circularity objectives. Now, just a few words of introduction. My name is Vasilis Rizos. I'm head of Sustainable Resource and Circular Economy at CEPS, and I will moderate this discussion. Now, I think it is well known today that plastics are employed really in a very wide range of sectors. Some of them are packaging, construction, electronics, automotive, agriculture, to name a few. And while, of course, plastics have a myriad of different applications and uses in all of these different sectors, in recent years, there has been increasing attention on the issues of plastic pollution and plastic waste generation. Now, some of the impacts of plastic linked to waste generation that have been well documented in the literature include damage to marine ecosystems, of course, generation of CO2 emissions, health impacts. I think these kind of implications are well known, and there have been several publications raising these issues. Now, at the EU level, there has been a response, let's say, to these concerns, and there is a dedicated strategy on plastics in 2018. I have to say that similar government-wide initiatives have been emerging in other parts of the world as well. For example, in Canada, there is a strategy on zero plastic waste. So despite we have strategies in place, high-level strategies that in many cases, and especially in Europe, have been translated into concrete legislative action, plastic waste generation is still very high. And if you look into the literature and different studies, there are even projections that could even increase in the coming decades globally. Now, there has been debate for some time about whether one of the potential solutions to this plastic waste challenge could come from a group of different technologies that are often referred as chemical recycling, and they aim to change the material structure of plastics. Now, if you look into the existing evidence, some of these technologies are not new and they exist at different development stages in some time ago. However, recently there have been certainly quite a few announcements for the development of new chemical recycling facilities in Europe and abroad. So this certainly shows that there is, I would say, increased interest in further deploying this technology. Now, in view of this kind of, let's say, updates and evidence, we have assembled today a panel of experts from academia, industry, NGOs, and policy in order to have a discussion on the state of play of these technologies, the existing opportunities and challenges that exist or are linked to the further scaling up of chemical recycling technologies in Europe, and ultimately have a debate around the question of whether and under what conditions chemical recycling could make an important contribution to the EU circularity and decarbonisation objectives. Now, this discussion is also very timely because in the context of implementing the EU Single-Use Plastics Directive, there are some ongoing processes or efforts to develop a methodology for calculating the recycled content in products. So hopefully our discussion can provide some useful inputs to these policy developments as well. Now, just a few words regarding the structure of the event and our speakers. First, we will kick off the discussion with Matthew Jones, who is professor at the Department of Chemistry at the Center for Sustainable and Circular Technologies at the University of Bath. Matthew will set the scene for discussion today. He will provide an overview of different chemical recycling technologies and in general his views on the prospects of all of these different technologies. And directly after his contribution, there will be a possibility to answer some questions. So feel free to start sending your questions while he will be giving his presentation. Then we will move on to a panel discussion, and we will start with Chloé Rago, who is head of policy and sustainability at Plastic Energy, which is a company that uses one of the technologies that fall within the scope of chemical recycling. Then we will continue with Christian Kroger, who is a circular economy expert at BASF, the large chemical producer who has also launched chemical recycling projects, as we will hear later. Then we will have the perspectives of Yannick Wang, who is climate, energy, and air pollution coordinator at Zero Waste Europe, which is a Brussels-based NGO that is doing a lot of work on plastics and specifically on chemical recycling. And finally, we will continue with Sylvia Ai, who is deputy head of the Waste Management and Secondary Materials Unit at the DG Environment of the European Commission, and she will have the opportunity to react on the contributions directly after the contributions of the industry and the NGO representatives. Now, beyond Matthew, all four panels will have around 7-8 minutes for their initial contribution, and then we will move on to discussion, where we would like to bring some of the points raised in the chat room and also some questions from myself as well. So feel free to use the chat or Q&A function of Zoom, and I'm sure that after quite a few months into lockdowns and digital kind of teleworking experiences, you are all familiar with this function, so feel free to use it. Please mention your name and also your organization in order to know where these questions come from and bring them accurately, let's say, in the debate. Finally, to say that the event is currently live streamed on our SEPS YouTube channel and also will be made available later in case you would like to go back to some of the arguments raised today. So now, with no further delay, I would like to give the floor to Matthew Jones. Matthew, first of all, thank you for taking the time to be with us today. Now, a good part of your daily research is dedicated on chemical recycling, so I'm sure you have a lot of interesting insights to share with us and help us kick off this discussion today. So the floor is all yours.
Thank you very much. Hopefully you can see my screen okay. So thank you very much for that kind introduction. And I must just say one thing now, you reminded me that we have rebranded ourselves as the Centre for Sustainable Circular Technologies. I'm using the old branding of our PowerPoint slides here. So this should be Centre for Sustainable and Circular Technologies. You are correct. So what I want to do today is just, I'll be brief, 10 minutes max, just to give you a little bit of an overview of some of the work that we're doing here at the University of Bath, which is based in the southwest of England, and just to give you sort of my views on where I see chemical recycling and some potential questions and answers. So obviously it goes without saying that the vast majority of the plastic that we use is mostly derived from oil. And so there is a need to move away from that. And I think now is a real watershed moment for both academia and industry, that we need to sort of look at new ways of making petrochemicals and plastics. And I think that chemical recycling has a lot to offer in this space. So you can look at in the last, I think it was about 5 or 6 years ago when Coca-Cola introduced part of its recycling for its PET, what a good marketing strategy that was. And I think the EU, and I never know whether to include the UK in the EU still, who knows, but the EU and the UK on banning the single-use plastic, I think is a good policy-driven approach as well. But is sort of chemical recycling, is it an opportunity or is it a white elephant? So in English, if we say white elephant, that means something that costs us a lot of money and delivers us very little. And I hope that after the end of these talks today, that you'll see that chemical recycling is an opportunity for us. So what actually is the real problem here? So since about 1950, and I must cite this, if you've not seen this paper here in Scientific Advances, it's a really good read, and it really helps to set the scene. So what actually is the problem? So since about 1950, we have, as a society, produced 8,300 million metric tons of plastic. That is more than sort of living biomass. So there's more plastic in the world than there is actual biomass. Some of it is still in use. Some of it has been discarded into the ocean, some of it or to landfill, incinerated, and a small proportion of plastic is being recycled.
Matthew, is it possible to go into presentation mode? That will make your slides even more. I mean, now you have it. You don't have it in presentation mode, and I think it's not the best way of presenting your slides. I think if you right click with your mouse, probably you can see the presentation mode option.
Matthew, please go on top to your display setting, on the top bar, and click swap screen. Left on the top bar, a bit up.
Oh, I see.
Yes, just swap screens.
Okay,
all right,
sorry.
Thank you.
Sorry, yes. Okay, sorry about that. So we have made about 8,300 million metric tons of plastic since 1950. So when plastics were first sort of invented, they were hailed as an environmental success. And I really think plastic is an environmental success, but it is now turning into an environmental problem as well. Plastics have got such wonderful properties. For example, they're lightweight, durable, and flexible. And it is easier to make bottles out of plastic than it is using glass. So I don't think just sort of stopping using plastic is actually the answer to some of these problems. We just need to be cleverer with the end of life options. The other problem is in the economy that we currently employ. So we have the linear economy, where we extract a resource, we make something, we distribute it, we consume it, and then we use it and we throw it away. So it's effectively a make, use, dispose lifestyle. And we need, as a society, we need to move away from this. And the circular economy is a potential solution for this. So we can still extract, produce, consume, and we can waste, but then instead of sending it to landfill, we can either recycle it or we can upcycle it into a more higher value chemical. So again, I don't think stopping using plastic is the answer, but I also don't think just producing the single-use plastics is the answer as well. There's been in the last 18 months, unfortunately, since COVID, we've probably seen a lot more plastic waste as well, a lot more medical waste. So I think there might still be an argument for single-use plastics for medical waste, but I think for consumer goods, we need to move away from single-use plastics. So here's a bit of, this is a slide I use in my first year thermodynamics lectures to the undergraduates. So polymerizations, if you do the temperature under a ceiling temperature, if you do it at a lower temperature, you can take your monomers and you can make your polymer. But it is theoretically possible to, because this is an equilibrium process, to increase the temperature above the so-called ceiling temperature and convert your polymer back into your monomers. And I say that that is theoretically possible. It might always not be doable, but it's theoretically possible. And you can also take your polymer and you can upcycle this into higher value added chemicals. And so some of these processes, so the depolymerization might work for some plastics, or the upcycling might work for other plastics, but there isn't necessarily a one size fits all approach. And what I also think is important is to realize at the moment there's potential for the chemical recycling and there's also mechanical recycling. And I don't think it is an either process. I don't think it's either mechanical or either chemical recycling. I think it's really important to view these as complementary technologies, and they shouldn't be viewed, I don't think, as competitive technologies. I think what might work for one plastic might not work for another. So I think it's fair to say, and I've used italics here, I think it's fair to say that mechanical recycling can be limited to a few cycles and it may lead to downcycling. But I think one of the advantages of chemical recycling, it is possible to obtain sort of virgin monomers again that can then be used to repolymerize and to make your plastics and polymers with exactly the same properties. So effectively, you're breaking everything down at the molecular level. What's important in both of these technologies is obviously the sorting and the washing of plastics. And I think what we have to be careful of, and I think it can be important also in mechanical, but it's also important in chemical recycling, is we've got to know what's in the plastic in the first place. So any fillers and pigments and plasticizers. And I think also there is a role to try to make things simple. Can we design a material that is easy, that will be more easily chemically recycled, i.e. it doesn't have layers of plastic built up on top of each other. So I first sort of got into looking at polymers maybe 10 years ago. And one of the first sort of materials that we looked at is making PLA, which is polylactic acid, which is a biorenewable and biodegradable polymer, which you can make from the fermentation of starch-rich products. You can make the monomer, and then we can open that and make the polymer. This is quite an energy-intensive process. And one of the advantages of this plastic is that it's also biodegradable. But we kind of thought, well, if there's a lot of energy that goes in to the plastic of making the plastic in the first place, is there any way that we can keep the carbon that is embedded in there, the energy that is embedded in this material, in its high value? So the first plastic we looked at was trying to recycle PLA. We have a lot of expertise in actually making plastics as well, so we can make sort of various grades of PLA, but that's a different story. So what we wanted to try to do was see if there's any way of sort of degrading PLA into lactic acids and to lactic esters via a simple catalytic process. So we were able to develop a series of transition metal based systems that can break down PLA. So it's possible to use the same catalyst to make the polymer, keep the catalyst in the plastic, then add some methanol into the material and actually degrade your plastic back into a lactic ester, which you can then either use as a solvent or in perfumes, or you can use that to make the monomer again and to close the loop. However, what is also important, and I do appreciate this, that the PLA is at the moment, it is a relatively niche plastic, but it's becoming more important. So what we've been looking at in Bath in the last couple of years is trying to look at other polyesters and can we chemically recycle other polyesters. So obviously, the obvious example here is PET. So we spent a lot of time looking at PET and trying to convert this back down into its monomers. So we can either do something called methanolysis to break down PET into ethylene glycol and DMT, or instead of using methanol, we can use ethylene glycol and make this compound at the bottom here. And what I think is really also important in this kind of processes is that the chemistry must be simple. We need relatively simple catalysts for this process because we don't want to develop something that's going to be the catalyst itself is going to be incredibly expensive. So we've been looking at relatively simple processes. So we can take sort of these salts, and we can actually go to our local supermarket, buy, I shan't say what brand of PET bottles we have, but we can take the bottles, we can degrade the PET plastic at relatively mild conditions. I think we do this at about 150 degrees. We can then make the monomers, and what we can show via here is a DSC image of, so here is just showing that the properties of the polymer are exactly the same. So this is the bottle that we buy. This is commercial material from Merck. And then what we've done is we've taken the plastic, we've chemically recycled it, and then we then have done the polycondensation to reform PET, and we've shown that it's got very similar chemical properties as the starting material. So what we're looking at now is trying to expand upon this work. And I think where we're going here is trying to look at sort of mixed streams. Can we also target polyamides and polycarbonates? I think key challenges here are on the sort of the separation, and it may even be easier to immobilize the catalyst on a support. But I think some of the questions that I think we need to sort of look at is we need to sort of, instead of viewing plastic as a waste, I think it's really important to start viewing this as a useful form, to treat plastic as the source of carbon or as the source for chemical industries. What can we convert the plastic, the waste materials to? And I don't think also that chemical recycling, I don't think it should be marketed as a way of reducing pollution. I think we still need to encourage the reuse of the materials as well. And also in this sort of area, I think partnerships and policy will be the key drivers of this. And it is super important as well to look at the entire life cycle assessment of the processes as well, just to make sure is actually what we're doing actually making saving the carbon and saving the energy that we think it will do. And this is one thing we're doing at the moment, just looking at the LCA of some of our processes. And finally, I'd just like to thank the people who have done the work, Paul and Jack, who did some of the recycling studies, and the Engineering and Physical Science Research Council here in the UK. And also just to thank Vasilios and Seps for the invitation to speak today. And finally, I hope you all enjoy watching the football this evening. Thank you.
Good. Thank you, Matthew. I forgot to say good luck regarding the game later. And okay, so thanks for this overview of your research. And I think there were some very useful perspectives there. And I would like to come back to some of these points. Now, I saw that there have been some questions from the audience, and even a couple of participants raised their hands. So can I just kindly ask you to use the chat room to pose your questions, because otherwise it can be an issue if we open the floor to everyone. There can be technical issues. We have tried this in the past and it hasn't worked. So please use the chat function to raise your questions. Now, there have been some questions touching a little bit on the theoretical kind of foundations of what is a circular economy, and whether converting chemical waste into higher quality chemicals even can be considered as circular, while we should only consider circular processes when we turn recovered plastics into new feedstocks for new plastics, let's say. And that, I think that, yeah, we can have a lot of discussions on this and around the concept of circular economy. I don't know if you have any thoughts on this, and then I have a couple of thoughts as well. Yeah.
I think it varies on a case-by-case basis. So in my opinion, I think you'd have to look at it, and if it is better to convert the plastic back into the monomer to remake the monomer, I think that's great. But I also think if there is a case for converting the plastic, if say, for example, you can convert it into a solvent that can be used in another industry, then I think if the chemical recycling is too much energy intensive, then and that's a route that you should employ afterwards, if that kind of makes a bit of sense.
Okay, thanks. Now, Matthew, I mean, to enter a little bit even further in theoretical discussions, you mentioned the law of thermodynamics, and I think it is well known that according to the second law of thermodynamics, there are, let's say, physical constraints in transforming waste to another product with 100% efficiency, because there will always be some losses in the system. So if we cannot achieve this 100% efficiency for plastics or even other types of materials, I was wondering, because you mentioned during the discussion that you see a lot of prospect on improving the efficiency of these technologies. I mean, what is really the concrete evidence you have from this, or you see in your research, and whether these evidence are still on a lab scale, and we're very far away from achieving this kind of outputs at the practical plant level. And also whether there are any big trade-offs. I mean, achieving a very high percentage of efficiency and transformation could be an option, but then are there any important trade-offs here in terms of energy consumption? Yeah.
So I'd be interested for the industrial viewpoint on that question as well. But I would say that there are, so with the chemical recycling, I think it at the moment, well, I think there's a lot of, in the last 10, 15 years, there've been sort of easier ways to do things, separation of materials, I think, and separation at the end of your product from any waste, I think is key. And I think in the last 20 years, there've been improvements in the engineering and the processes in that sort of area as well. And sorry, I can't remember what your last point was there.
Whether there are any big trade-offs with energy consumption. So if we are really trying to improve the efficiency of this process and achieve a high percentage of efficiency in terms of outputs, whether this would come with big trade-offs in terms of energy consumption or other trade-offs.
I think it also depends where the energy is coming from, but I think you need to look at the the life cycle of everything, and just if say the chemical recycle or the recycling is super energy intensive, then is that actually the right thing that you should be doing with the material? Is there something else that you could do with it?
Okay. I saw a point by Helmut Maurer that asks if or raises the issue that the chat function is disabled, but I think you can use the Q&A function, Helmut, if possible. Now, Matthew, you touched briefly on the LCA gaps, and I don't know if you have further insights to share on this, but I was wondering where do you see the big gaps? And I have to say that reading into the literature and looking into the different studies, you can see many researchers, scientists raising this point that we don't have. That in many cases, the evidence is not there yet to the extent it should be. So yeah, I guess maybe that sounds a little bit of a general argument, but do you see specific gaps that needs to be addressed in the short term, let's say?
So I think at LCA is quite an up and coming sort of area. Maybe it's about 10, 15 years old. And I think one of the key challenges is looking at the LCA on trying to sort of see if I do something on a small scale in a lab and look at the LCA of that, how does that actually compare to sort of a larger scale plant, or actually how do they compare? And so I think throughout the process at the small scale, medium scale up, and in the production, we've got to look at the overall assessment just to make sure, are we actually going to save any carbon at all? Okay, and do you think that these kind of assessments, they haven't been done to the extent possible so far? I think they're being done, but I think it would be useful to have a sort of a standard approach to it, for sure. We'll come back to these points later as well, Matthew. Now I've seen that there are a couple of more technical questions, but it would be useful, I think, to pick a couple of them. Now, Matthew Jones, Dr. Anja Pieper asks a question for you, Matthew. Normally we look at pyrolysis or solvolysis when talking about chemical recycling. Can catalytic conversion be applied with mixed plastic waste or plastic waste containing substances of concern like flame retardants or plasticizers? Plasticizers, yeah. Plasticizers. I guess it refers to whether the later will be the only option for this knowledge. So I think this could be an area where sort of clever catalytic design could come into play. So I could potentially see a scenario where you can degrade the plastic and leave the plasticizer or the flame retardant behind, depending upon what the chemical composition of those are. And I think it could be used for mixed plastic waste. So we have only at a small scale made some of our systems where we've used mixed plastics, and by changing the conditions which you do the depolymerization at, you can specifically depolymerization one plastic preferentially to another. Okay. But I do think more work needs to be done on understanding what are the extra things in the plastics, like the fillers and the flame retardants. Okay. Matthew, I mean, obviously we have quite a lot of people, policymakers in the audience as well. And I assume you will stay later for the panel discussion as well. So absolutely, we will come back. But I will just a question from my side, irrespective of whether UK can be considered as part of the EU as well. You mentioned in your last slide that there is a need for some policy updates, some policy kind of revisions. So I was wondering if you could elaborate a little bit of which are the areas more generally, or even more specifically, where you think that the policy framework is missing. Well, maybe not missing, but I think changes in government and changes in policy, I think those are, to make a pun on catalyst, the catalysts for change. So I think certainly in the UK, it was maybe about 7 or 8 years ago when we had Theresa May, they had the policy where we had to pay for plastic bags, and that overnight saw a dramatic reduction in the plastics, in sort of the litter that you saw in the streets. And I think if the EU and governments can mandate how much sort of recycled material needs to be on the market by 2030, then that will then necessitate the research, which will then get translated into industry, which will get translated into the process.
Okay. We have one last question from Helmut Maurer that he compares mechanical recycling with chemical recycling. I think you already touched that in your presentation of mechanical recycling cannot really provide the solution to all different types of mixed plastic waste. There are limitations. So yeah, I don't know if you have anything else to add this kind of discussion on chemical versus mechanical recycling kind of discussion, and whether you think in the coming years with more innovation coming in, maybe we will have more evidence to change this discussion or to divert this to a discussion to a different course, let's say.
Yeah, so just to re-emphasize the point I made, I think both mechanical and chemical recycling are complementary to each other. I think it will depend on a material by material, but it kind of varies from what you read in the literature, but from some of the academic journals I read, that they say that mechanical recycling eventually really goes to downcycling. So once you've sort of done your mechanical recycling, it doesn't necessarily generate the material with exactly the same properties. Whereas chemically recycling has the potential to do that. So theoretically, if you do it right, you should be able to recycle your material as many times as you want, and because you're recycling back to the virgin monomers, you can then make the material with exactly the same properties every time.
Yeah, but Matthew, that last point, I guess, refers to some specific chemical recycling technologies, not all of them, just to be specific.
Not all of them, no. Yeah.
Okay, good. Now, there have been a couple of questions that I think they also relate the discussion later. I think, what are we going to do with the huge amount of plastic we have already produced? I think you touched a little bit about, Matthew, that some of these options, they are already in place. They're not just on the laboratory scale, but until a good question that maybe the other participants can answer as well. And then the comparison of pyrolysis with waste to energy. I think we have industry representatives later that they work on it, and they will have I'm sure they will provide perspectives of why pyrolysis is different than waste to energy, basically. Matthew, I mean, if you allow me, maybe we can move on to the floor to the other panelists, and then you will be with us. You can always come back to the discussion. I will actually ask you later to come back to the discussion directly.
Thank you.
Perfect. No, thank you, Matthew. Now I will move on to Chloé Rago. Chloé, first of all, thank you for taking that time to present your work today. I know that Plastic Energy is investing a lot on chemical recycling processes, and from what I saw on your website, you have even plans to expand these operations international. So I guess there are some good reasons for this. So we look forward to your perspectives, recommendations, and even concerns that you might have to share with us.
Yeah, thank you very much. Can you hear me properly?
Yes, very well.
Yes, okay, perfect, great. So hello everyone, and thank you very much for having me today. Yeah, perfect. So I'm going to start, with a simple question to kind of, go back to the basics and make sure we all have, I would say, the same background to start this conversation. So I will start with, the simple question of why is chemical recycling, relevant today, and why do we talk about it more and more, especially in policy. So first, I would say that it helps reach recycling targets and recycled content targets. The second point is that it enables the incorporation of high quality recycled content into food grade products. Again, depending on the type of technology, and it increases the recyclability of some of the more difficult plastics. Again, not all. I'm going to go quickly over those slides because I guess it does repeat slightly what I'm sure many of the presenter will present. But I very much want to insist on the fact that we are not competing with mechanical recycling, but we're very much complementing it. And here, both recycling methods very much aim to divert plastic waste away from the linear economy, so basically away from incineration or landfilling. So you can see, there is a very well built and evolving mechanical recycling loop in yellow that is, working well and, will further improve. And for the plastic that basically are not mechanically recyclable, instead of going currently to for instance, landfilling or incineration, basically what we do is take some of those plastics. We cannot take them necessarily all, but take some of those plastic and create a new recycling loop through chemical recycling methods, so through various technologies here. The idea obviously being to enable to create a circular economy for plastics. So this basically means that all solutions here are needed to reach the EU target and create a circular economy for plastics. So technologies are complementary. So they target different plastic waste and create different output and different quality output. Both of them will evolve and improve, and will further basically improve recycling rates at the end of the day. So for instance, here, if we look at mechanical recycling, so it tends to excel, for instance, at recycling large and homogeneous streams of especially rigid plastic waste, obviously not only, and usually needs some washing and cleaning to have, let's say, cleaner waste streams. At the end of the day, it can create very high quality output, especially when it comes to PET. For other material, it tends to downcycle. So obviously there is a demand for those products, but doesn't necessarily suit all applications. So including, for instance, food grade applications. And so here, that's where for instance, chemical recycling comes in, overcoming some of those limits, and especially in filling, I would say, the gap in terms of recycled content for food grade applications. So here, chemical recycling can take usually more multi-layered or contaminated or flexible plastics that usually are difficult. So difficult economically, but also technically for mechanical recyclers. And at the end of the day, the goal, and again, here there is some differences that I'm going to dive into between different types of technology, but the idea is that it creates a very high quality output. And for some of the technologies, basically, it is being used as virgin quality recycled content, so can be used in food grade products. So I'm not going to dive too much into the details, but here it is just to highlight the different, let's say, main groups of chemical recycling technologies, and the important differences between them. Usually we say chemical recycling and as, let's say, one technologies. It is not one technology, and actually there are a lot of differences between them. And here I want to highlight the fact that even among chemical recycling technologies, there is also some complementarity. So for instance, just to highlight a couple of examples for you to understand some of the differences. So if you look at depolymerization, usually it needs some monostreams. So for instance, a monostream of PET or a monostream of PA. And compared to pyrolysis, which needs mixed streams of polyolefins, so mainly PP and PE. In the same way, depolymerization likes PET, pyrolysis doesn't like PET. So here you can see some of the differences in the input plastic, but also in the output. So you can see many of the outputs on the right side, and those can be used in different ways to recreate products. Here, mainly what I want to say is that basically many say that chemical recycling doesn't exist yet. However, what I want to highlight is the fact that it is already a reality. Although it is at small capacity, it is true. But it is very much onto the market and commercialized. At least it is the case for Plastic Energy, my company. It is also the case for a couple of other companies. So here, for instance, for us, we have two commercial plants that have been operating for the past 4 years. And we are developing more plants. So there is 4 projects across Europe, large-scale project this time, that will be rolled out basically between 2022 and 2024, more or less. So it means that we do have operational experience, and we have created basically the output product to enable the creation of virgin quality recycled content that can be used for food grade packaging. And you can see on the right side of the screen 2 examples. There are more examples, but here it was just to highlight that some examples are already on the market. So for instance, the Magnum or the Knorr jars, tubs, are already on the European market, and in it there is some of our output basically, and more than 7 million of those tubs are already on the market. So it is obviously still small, but very much growing, and will further grow as the company and the industry, generally speaking, upscales. You can see also on the right side the cling film around one of these cheese that is sold at Tesco. So here we've in addition shown the full loop, the closed loop. So basically we've taken some plastic waste from Tesco and basically back into Tesco after the full value chain. So here, just quickly highlighting some of the results of life cycle analysis. Here, I'm not going to dive into much details, but more than happy to discuss it during the conversation. But what we have found currently in many of the industry and actually non-industry LCAs is that basically there is, generally speaking, a lower environmental impact than incineration with waste with energy recovery, and also a lower environmental impact than making plastics basically from fossil sources. There is also usually, and again it depends on technologies, a higher environmental impact than mechanical recycling. However, here I want to highlight that this environmental impact doesn't take into account the fact that we are taking different types of plastic than mechanical recyclers can take and create a different quality output. And here I think it is very important to highlight this difference. And finally, many of the chemical recyclers in the industry are participating currently in a commission LCA that is being organized. And finally, my last slide is very much focused on the policy environment. The fact that it is generally supportive. We all see that there is more and more supportive policies when it comes to collection, sorting, recycling, recycled content. So very much trying to incentivize all those aspects and incentivize the respect for the waste hierarchy. There is also a positive evolution towards the recognition of chemical recycling, although still at a high level, at a theoretical level, and not necessarily in the application. And here it's very much in this application that we find many challenges as chemical recyclers. And many items currently are in discussion, so it will evolve, but currently it is still undefined in its implementation. So one of the aspects is very much the lack of clarity on the methodology to calculate recycling rates or recycled content, or a common understanding of the mass balance approach. There is also a lack of level playing fields between mechanical and chemical recycling, especially when it comes to the inclusion in EPR schemes. Obviously, we need to be included, given that we are doing recycling. The current waste system tend to have basically short-term contract, which obviously makes it difficult to secure plastic waste. There's a lot of lack of harmonization in end of waste legislation between different member states, and finally there is still let's say no formal policy recognition that chemical recycling output can be used in food grade application, although there is some allowances that have been granted on that side. So overall, basically this lack of policy clarity, especially in an innovative industry, creates a complicated environment, both to invest for SMEs like us, but also leads to let's say more difficulty to access to plastic waste today that could be recycled. So that's all on my side, and more than happy to respond to questions.
Chloe, many thanks for your contribution. I think you raised some very useful answers. You were very open regarding the difference of the different technologies, and not all of them are employed from your company, as you mentioned, but you recognize that we're not talking about one specific technology. Now there are many questions of very technical nature. I'm not sure if we can go into them now, and quite a few of them I think refer to all speakers. So I'm just going to pick a couple of points here, and I will let you then prepare yourself to provide overviews in all of these different questions after the round of 4 speakers. So there is one specific question for you about whether you have actually calculated the specific output that can come out of 1 ton of plastic. For example, if there is 1 ton of plastics entering your plants, if you have really calculated how much can be used as a useful material after repolymerization. And I guess maybe this is a little bit complex because there are different types of outputs, as I understand from the process. Then I don't know if you want to share something else on the comparison between waste to energy and your specific process. I understand that there is an ongoing process by the Commission where you will feed in some information. But I was wondering, what do you feel, if you think that the evidence is there and if you feel very strong about it? And yeah, maybe I stop here. As I said, there are really a lot of questions, and maybe I will allow you to prepare later and pick some of them as well. Please.
Yeah, no problem. So regarding the first question, which I guess basically is about yields of the process. So basically, out of 1 ton of plastic, usually there is about 850 liters of what we call tack oil, so pyrolysis oil, that is being created. Then there's also a synthetic gases and a byproduct called the char. And here basically what we do is use all the pyrolysis oil, so the tack oil, so those 850 liters in this case, as a feedstock in the petrochemical industry. So basically we sell that feedstock to petrochemical companies that then can convert it into new plastics. So currently it is very much the focus of our activity, and we have used actually all our tack oil for pure recycling purposes for the past now almost 2 years. So it is in that sense, very much a reality, and all that liquid recycled oil created is being used for recycling purposes. When it comes to, and I guess it links to your second questions on waste to energy versus chemical recycling. I mean, here the main difference is that we use our product is used as a feedstock, as a new feedstock for the petrochemical industry to replace virgin and fossil naphtha. Waste to energy is obviously leads to if we would use the product in waste to energy, for instance, it would mean burning the product and therefore not creating a circular economy. So I don't know if the question was more precise than that, in which case I'm more than happy to clarify further, but that's the, I guess, high level differences.
Okay. And regarding your investments in other parts of the world, I was wondering, are you following those developments in these regions? I mean, do you perhaps see that there's more fertile ground for these investments in other parts of the world than Europe, or you think Europe is actually the most advanced region in terms of investing in this?
Yeah, I would say that Europe is the most advanced region, mainly because it is, despite the fact that there is still, a lot of improvement that should happen in terms of waste management. It is still the region with the best waste management system and most organized, with also some, let's say, support such as the EPR scheme. But some more regions are already moving quite a lot, and that includes the US, Korea, and quite a few other regions.
Thanks very much, Chloe. We will come back to some of these points, and you will have more opportunities later to answer some of the questions. Now, I would like to move to Christian Kroger. Christian, thank you for joining us today. I think BASF is very much present in the discussions around chemical recycling. And you have launched dedicated projects on this technology. You have also developed partnerships with other organizations, as I've seen. So yeah, we're very much looking forward to hear your perspectives and views based on your work.
Yeah, thanks, Vasilios. Do you see one slide or two slides?
I think you still need to go to presenter view.
Okay. So now I think should work. That's one slide. Yeah, thanks for the invitation to this very good event that we discuss chemical recycling from different perspectives. What I would like to give you as an input is why chemical recycling for us as BASF is an opportunity for a decarbonized and a circular economy. Yeah? And why we are really engaging since a couple of years already quite intensively in this area to build up our supply chain, also investing in our upstream partners already, and also investing in how to use such, let's say, new feedstocks for the chemical industry to bring us more into a circular one. Yeah? And just before I start that as a content, you must know that the chemical industry is still 90% linear. Yeah, so we are depending on oil and gas, and only roughly 10% is bio, and recycling does not really play a role, you can say, for us. And therefore, we are at the beginning of this journey, and we are really willing to change that. And chemical recycling is one of the opportunities which I will show you now to begin this journey. First coming, and also the previous speakers have already told something about that, we have challenges now, and we will have challenges in the future with plastic waste. Yeah? You know that for mixed plastic waste, especially, we know that from tires, you know that from other things. Yeah, just some numbers to remind, which brings that a little bit more into a perspective. Today, we have 250 million tons of global plastics production, and roughly 40% is mismanaged from a global perspective, even also open burning, for example. 40% is disposed, landfilling, and incineration. And due to a study from Systemic, they expect that this is increased to 450 million tons of global plastic production. And still 10% they expect that is mismanaged, and 23% which is disposed. So that means 10% mismanaged is 45 million tons, and disposing would be landfilling and incineration is still, let's say, 80 to 90 million tons of global plastic production is still in the wrong direction, going into a wrong end of life. So there is a big challenge today, and a big challenge will be tomorrow. And as a chemist, and for me, it's always good to have a lot of opportunities where I can do recycling, not only focus on one recycling method. And therefore, I would like to go more into detail in which different recycling methods do we have, actually. If I can turn the slide, yes. Now you see a typical value chain of where the chemical industry plays a role. Yeah, we have at the beginning, we have refinery. They have oil and gas as major feedstocks. Yeah, then they produce a naphtha. This is going into a steam cracker, the main petrochemical plant. You can say this is out of that. Polymers are produced, and then it's going into convert into plastics production. And after the use phase, it's a plastic waste. You know that after we have recovery, you have disposal, either it's going to landfill and littering, or to incineration, which is waste to fuel. And there are different now recycling methods. One is mechanical recycling, where you go back to the polymer itself. Yeah. And also you have chemical recycling, different methods like decarbonisation, where you can go back to the monomer, and you have chemical recycling like pyrolysis, which Chloe from Plastic Energy was presenting, but also gasification as a technology, where you go back really to the molecules where you can build up the chemistry again. So recycling, and that's for me as a technologist and a sustainability guy, yeah, is important. For me, recycling is reducing fossil resource consumption, and that should help us to be really free of plastic waste. Yeah? And when I see those numbers from those studies, I still see a big challenge even for the next 30 years for us. And BASF's ChemCycling project, that what we have started for 2-3 years ago. This is focusing on chemical recycling and on pyrolysis. this is for us one of the key pillar technologies to meet that future challenges, especially on those unsolved plastic waste problems. Mechanical recycling. It's already mentioned by previous speakers. They have some problems. We have high losses and also throughout the value chain, and which has still to be incinerated. That's not for all applications for sure, but for some, And also the performance is lost. The best polymer you can say, or best plastics, is PET. You can recycle PET 8 times before it's losing its technical performance. But for other polymers, this is already after the first cycle. So PE, for example, for many applications, you cannot use again after mechanical recycling for the same application to 100%. So there is, from the technical side, a need for other recycling methods, and therefore I'm glad that we have also chemical recycling, like depolymerization, but depolymerization works only for some plastics. Chloe has mentioned that for polyamide and polyurethane, for one of the two big plastics kinds, it works, but still for polyurethanes, we are more in the R&D stage, but for polyamide, it's quite advanced already. But chemical recycling, to my opinion, either is pyrolysis and gasification. We think pyrolysis is currently the more potential method. This is the opportunity for us to further reduce the plastic waste. To further reduce that means complementary to mechanical recycling and chemical recycling to monomers. And what concrete waste streams? Because we are always asked, which concrete waste streams are you really recycling? Or is it just something which you always say that you can go back into cycles? Concrete, you can say that mixed plastic waste, for example, from yellow bag system, EPR systems, it's still an unsolved problem also in Germany or throughout in Europe, that it's mainly incinerated, or it's incinerated. And incineration means waste to energy, and waste to energy means it's okay, you can get energy, but it's converted to CO2. So it's not good for even for CO2 emissions, for the climate change. And this is, I think, an opportunity for pyrolysis, where you have yields of 70 and probably also in future higher yields, where you can make also some materials out of it, or an oil where you can make materials out of it. Tires, there are millions of tons still in the European Union of tire waste, which is completely incinerated or landfilled. This could be also converted into pyrolysis oil, you can say, from end-of-life tires, or at least partly, and that can be also used as a feedstock, eligible feedstock for the chemical industry. So also here you can see that even from the EU waste hierarchy, you could turn something from incineration or landfill to recycling. And what is key for chemical recycling? Chemical recycling will never fly for the chemical industry without a mass balance approach, without applying a mass balance approach. And a mass balance is a chain of custody model where you have certification. So you have a certified recycled content which is going into the chemical industry. So you have a traceable also recycled content going through the value chains. By that, you do not need any reformulation as a customer. So they can use the products as they get it, with the identical product performance. And that's very important. Think about the automotive industry with all the safety regulations. When they want to use recycling, they cannot have degraded polymers. They need to have really to meet the safety requirements, what is important for us all. Available, easy and fast for nearly all of our products. That's also true for our competitors for sure also. Because we are using existing assets, we do not have to build new assets. We do not have to invest into new R&D to make therefore chemicals out of it. So it's easily and already available. And it saves fossil resources, and what I will show you also after, reduces greenhouse gas emissions. And drives also the use of sustainable circular feedstock, because sustainable is for me because it's a waste what we are using as a chemical industry and not oil and gas. So it will substitute completely oil, or it could potentially substitute completely oil and gas. And here BASF has done also an LCA on that. It's public on our website. You can see that. And that's we've actually done 3 LCAs. This is just one snapshot out of it. Yeah, you have here incineration as one option, mechanical recycling, and pyrolysis. Yeah. So what is here shown is the plastics production, the CO2 emissions for plastics production. Yeah, that's for all 3 the same. And we have 3 different end-of-life options. We have used not our own BASF method on that. We have used the product environmental footprint method of the European Commission, or the JRC. Yeah, and therefore also we applied the circular footprint formula for that. Yeah. It's not a surprise that waste to energy is not the most favorable option in terms of CO2 emissions. Yeah. But it might be surprising that pyrolysis is close to mechanical recycling, and that mechanical recycling of mixed plastic waste, we're not talking about monofractions, yeah, so monopolymers, we're talking about mixed plastic waste. You can see even slight advantages or disadvantages in comparison to pyrolysis. That depends actually on the losses what you have, yeah, before doing mechanical recycling, and also on the quality output of after mechanical recycling. And the quality output, you also know, for example, you lose the food grade when you do mechanical recycling, yeah, but you lose also technical performance. So part of the potential application are not accessible with mechanical recycling. And this is the opportunity for pyrolysis to go into such applications, yeah, technically. And in terms of CO2 emissions, you see also that it is quite comparable or similar to even mechanical recycling, or it could be. I conclude that plastics in the environment is and will be a challenge. That's fully clear, and I think we need solutions for that. And chemical recycling can further reduce the plastic waste. Yeah, and therefore, to my opinion, there is no way out of it, at least short-term, mid-term, and also long-term, at least long-term. And applying the mass balance approach is key for chemical recycling. Yeah? And from the life cycle perspective, you see that pyrolysis shows benefits in terms of CO2 emissions. It has roughly, let's say, 50% less CO2 emissions compared to incineration. And the benefits versus mechanical recycling, this is case-specific. And we talk about mixed plastic waste for sure. Also here it is case-specific, but it could be better, but it could be also worse. That depends on the eligible and appropriate waste stream what you use. Yeah, thanks, and I'm very happy to answer questions now and later also in a discussion.
Okay, good. Thank you, Christian. Quite a lot of interesting information on that, and I have quite a few questions myself as well. Maybe I pick a couple of these questions that I also see in the audience, and then we come back to some of these issues later. Maybe I could just kindly ask people to, if possible, to use their names to know where the questions come from, because we see a lot of questions from anonymous attendees. It's always better to know the organization and the background than your background when you ask a question. Then there was a specific question for you, Christian, on the distinction between the BASF chem cycling process and the pyrolysis gasification. So basically, one anonymous attendee asks whether the chem cycling uses plastic waste feedstock already covered by the pyrolysis process, and shouldn't only the chem cycling / purification step be considered as chemical recycling, while pyrolysis and gasification should be considered as feedstock recycling, if I understand here correctly. So I guess what they mean here is that whether there should be a separation between these processes also when you use different terminologies. Maybe that's also linked to the mass balance question. And then another question I have myself is that you presented some good comparison on pyrolysis compared to mechanical recycling and incineration. I think that answers one of the questions of one of our attendees earlier, why we always speak about comparing, we always try to compare incineration with chemical recycling. I think honestly, if you look into research studies and even academic papers, most of them, that's what they do. They go into the process of comparing these two different processes. So I guess there are good reasons for this. But I was wondering, Christian, if in your modeling in BASF, first of all, if you have looked into other side effects of pyrolysis process, for example, beyond CO2 emissions, for example, perhaps generation of some side chemicals, let's say, or other effects beyond CO2 emissions, if they have been taken into account in your modeling. And also a third question here, maybe in terms of modeling, whether you have looked at BASF into future predictions of the types of plastic production we're going to have in the future. Many of these solutions, from what we see here, is targeting different types of plastics. I mean, we know that plastics might very likely will increase in the future, but have you done any predictions to see which types of plastics will be more prevalent in the future? Because that might be linked very well to the types of technologies where we need to invest at the moment. Maybe a lot of questions, but I can dig them again in case you missed something. Yeah.
Try to keep it short, these answers, because it might be not always very clear. Yeah, I mean, that's also. I mean, first the purification. It's already obvious that a purification is an important step after pyrolysis. Yeah, that's clear. Yeah, to come into large scale. I mean, into small scale, I think that might be can be done maybe without, but with large scale, I think purification is important. Yeah, for that we get as a feedstock for the petrochemical industry. Now, the next question was should be considered as recycling? Yeah, that you have different meanings. Yeah, because important is for me that from the legal perspective, you turn a waste into a product. Yeah, and that's the definition of the recycling. Yeah, and if your product is if your output is a product, yeah, then it is the recycling operation. And when you have a recycling operation, yeah, which includes for sure the purification, and it is done together with pyrolysis, yeah, then it's part of the recycling operation. That's fully clear. Yeah, but it is not yet clear whether after the chemical processes is considered also in the recycling process. To my opinion, not. Yeah, because it's a product what is used. So it's also a legal perspective as this question. Yeah. And also I think if if it is still considered as a waste, that is for sure fully clear. It has to be included. But if it's considered as a product, yeah, then I think it can be also considered as not to be part of the recycling process. Yeah. But this is still also under discussion, I must honestly say, also within the European Commission and with our dialogues with them. Yeah. And second question was why are we comparing with incineration? Because stakeholders are asking that. Yeah, because if you are failing already comparing with incineration, you do not need to start pushing chemical recycling, I think. Yeah, so that's the first question what you get. Yeah, the next question what you get is, yeah, is there a benefit in comparison to conventional products made out of oil and gas? That's the next question. Yeah, I did not show these results. You can see that also in our website. Yeah, we say yes from a holistical point of view. Yeah, we say yes because you can get some benefits for the society. Yeah, because you not only produce a new material, you also get rid of the waste. And if you consider that in your life cycle perspective, then you can see also these advantages in terms of CO2 emissions. Other environmental indicators, you have every LCA, it's always like that you can see advantages and disadvantages. This is normal in LCA. Yeah? For what for stakeholders is important is resource consumption. That's clear that this is less for chemical recycling comparison to fossil. Yeah? And that what we also ask is the toxicity. Therefore, first LCA is not really the appropriate tool, to my opinion. Yeah, because there's still you do not get the direct emissions coming out of a pyrolysis plant with an LCA. The indicators are really not very good, meaningful, and also the results. I can tell you the results also in the public, but the results are also not clear. Yeah, there are some who say, for example, it's also not clear in terms of a method. It depends which method are you applying. And the one you get a better one, better toxicity, and the other we get a less one. So there's a certain uncertainty, yeah, which I cannot give really a good and clear answer in terms of LCA perspective. But for the toxicity independent from LCA, a pyrolysis plant has to fulfill the regulations and also fulfill the threshold emissions, in the European Union, and these are very strict, and therefore the design of a pyrolysis plant and Plastic Energy have shown that it works on a commercial scale, that has to be completely fulfilled, and there's no toxic emissions, significant ones out of their chimney. Third, different types of plastics. I understand your question like that if you have, because it's so complex, the waste problem, and you have made so many waste types, we cannot only focus on one technology, how to recycle it, To my opinion, we need different kinds of technical solutions, or at least possibilities to find technical solutions for the dedicated waste streams, The big advantage for chemical recycling is that they can use, or at least pyrolysis, or gasification also, that you can use mixed plastic waste. You do not have to separate it. The most modern sorting plants can separate 50% monofractions out of a mixed plastic waste of a yellow bin, for example. So 50% is left. Maybe they can improve it to 55%, but you will see there is some kind of a technical limit. So there will be always mixed plastic waste available. And mechanical recycling is not the overall solution for this large amount of mixed plastic waste which is available in the European Union. So therefore, we need a technical solution anyhow. And therefore, I believe that chemical recycling is an option.
Listen, there is, we could expand on many of these arguments, and it would be nice if we had somebody in the panel from a sorting facility to elaborate a little bit on this figure, but we don't. And maybe we can come back to some of the ones. You will see that some of the questions from the audience are sometimes a little bit technical, and they concern some of your arguments, right? So maybe you can, if you want, you can respond also individually later. And on the mass balance, trust me, we will come back later. I will have also a couple of questions on this as well. Good. Many thanks for your contributions, and we will have more opportunities later to come back to discussion. Now I would like to turn to Yannick back. Yannick, thank you for your time today. I know you are working extensively on this topic. I'm not sure if you feel you have heard something new already, or if you were already familiar with all of this information and evidence. So what is really your take on all of these arguments you had earlier and on the different contributions, and where do you stand in debate and discussion?
Just a second. I think I need reverse the video. No.
Yes, you can reverse it there from display settings.
So where was it again? Here?
At the top bar, you have display settings, and then you can swap the screens.
Oh no. Screen 2. Okay. No.
Perfect.
What is it? Is it okay? Yeah.
Yeah. Perfect. Yeah.
Okay. Well, I thank you first of all, and sorry for this technical issue. It's always difficult to use two screens. I'm also very happy that actually my presentation is complementary to what has been presented so far, and actually going to add something interesting and focus very much on the issue of how we see that chemical recycling and recovery should be legislated in order to contribute to Europe's circularity and decarbonisation objectives. First of all, you must have noticed that I call it chemical recycling and recovery, and the reason for that being is that when we talk about currently about chemical recycling, we use this term actually to refer to a number of technologies that are very different in terms of their output, but also in terms of the residues and the corresponding environmental and climate impacts. Just a second. So let me start from this slide here, where you can see the different plastic use and plastic end-of-life waste treatment options. It's as you can see here on the slide, the priority, or it starts from use of plastic, so it's a plastic product, then it goes to reuse of of this product, and then it goes towards reuse of the polymer, and further it goes until it goes into monomers and simpler moleculars. And it's very clear that this kind of also shows a type of prioritization we need to follow, because the impacts, the corresponding impacts also increase the further down we go. And it's very important that we keep the value of those polymers as long as possible before we move towards the other options of treatment. So, and I think this is something that it's not discussed so much at the moment. I think I would particularly like to highlight, as I said, the very end options where we basically turn plastic waste to some sort of feedstock for petrochemicals. It's very far from keeping the polymer circular in the economy, circulating in the economy, and it should be always the last option. And there are different reasons for that. Not as I said, the impacts are very different for these processes, and also the output is very different. What we have seen is that, just to give you a few points on that, is actually quite a lot of carbon in this process is lost in the process. What we have seen so far, it's about 50% after purification is lost in the process, meaning very little is actually ending up in used in useful outputs. And and there is also a question on how much of it can be actually directly used, and if there is a need for actually diluting it with a virgin naphtha. And even more of it, the carbon is lost if some of it is burned in fuel. And we know that these processes actually, they produce quite a significant amount of byproducts that are simply getting burnt. So yeah, I think it's there needs to be a distinction between different types of treatment options here. And I think another interesting point, and this is something that we just released our new report, is to highlight the fact that we are in a very crucial moment at the moment in Europe, maybe also in the world, where we have realized that we have a plastic issue, we have a plastic pollution issue, and there's a lot of plastic out there which is simply not recyclable. And it's very hard to recycle, and the current recyclability claims are often without any grounds. So do we really want to now look at the options where we might recover some of the materials and mainly go into as a feedstock in petrochemical plants and lose a lot of this in the process? Or do we want to focus on actually creating a more circular plastics economy, where we focus on the reuse of the polymers but also, more important, the reuse of the products? So the focus, so there is a bit of an issue in here that by focusing too much on chemical processes that break down into molecules, we actually undermine the attempt to have a more sustainable products. So I think we have to be careful. So that's why we have a little picture here that where the horse is the other way around, and is that the kind of direction that we want to have? So I think the chemical recycling and recovery in particular should be the last resort. So we need to design products to be reused and mechanically recycled. Designing for mechanical recycling, it would also help to have them afterwards chemically recycled or even recovered. So, but the first option always has to be on mechanical recycling in here. Just I wanted to mention that of course we have been following the discussion on chemical recycling from the very beginning. And we have seen very few reports. I think most reports have the same conclusion. And the conclusion is that we still know very little about the environmental and climate impacts of these technologies. So I think we need to also have a bit of a cautious approach, and particularly when taking decisions, we need to know what are the impacts, potential impacts at the industrial scale. So talking about the impacts at the lab scale are not exactly the same as if we scale them up. So we need to know a little more about it. And then I just wanted to use a couple of more minutes here to talk about the policy recommendations. As I started off, there is a lot of confusion about what is actually chemical recycling, because we are referring to different technologies which have a very different impacts and need to be regulated very, very differently, in our opinion. So one of the first recommendations is to have a better understanding of the impacts of these processes at the industrial level prior we start encouraging those. Secondly and thirdly, we also need to have a clear definitions. We should not talk about chemical recycling as if we're just one thing. They are very different things. They have a different impacts. We need to have a clear definitions of what is chemical recycling and what is chemical recovery. And then we also need to have clarified the role of chemical recycling and recovery in the waste hierarchy. Our recommendation is that polymer to polymer processes should be legislated as recycling, while those going beyond to monomers and molecular should be legislated as a recovery, because that's what they are. And then finally, also we need to have some safeguards for different technologies to ensure that the most sustainable options are prioritized, and there will not happen any feedstock competition, diverting potentially feedstock, the plastic waste, from more sustainable options to more high carbon options. And finally, not finally, we also need to understand a little more about the climate impacts. I think here it's very important that we have a very honest LCAs and not compare it to different technologies and claiming avoided emissions. We need to know what are the emissions of chemical recycling per se, and not to start including different calculations which may lower the total emissions of these processes. And yeah, just to really finalize, two more recommendations. I think what is very important, particularly when it comes to processes where it's difficult to know how much of this is actually used as a recycled content, we need to have a very clear and strict rules to avoid any kind of greenwashing, because we are seeing pyrolysis plants, for example, claiming that they are producing yogurt cups. They are not, because they don't produce, they produce pyrolysis oil. So it's fed into a petrochemical plant where it can be eventually partially turned into yogurt cups. But that's a very long process. So I think we need to be very, very strict here and avoid any kind of greenwashing, and put them in, having clear rules for calculation of the recycled content. Finally, I think also we are living in a climate emergency, and EU has an important role to play here. And we strongly recommend that the processes which are higher in carbon should not be subsidized by the EU funds. And as I said, understanding which processes are more high carbon than others depend on a very honest and transparent life cycle assessment, which should not include any avoided emissions. Yeah, so I'll stop here. I just wanted to say that today we launched the paper, and we have done some other papers, and And if you have any questions, then please let me know.
Okay, very good. No, thank you for your time, Yannick, and for these useful views. You probably have seen quite a lot of questions in the chat room. Maybe we come back to some of them later. Now, I just a couple of remarks from my side. I was wondering, in one of your slides, you basically mentioned that reuse and mechanical recycling should always come higher in priority compared to chemical recycling. I was wondering if this refers to all types of chemical recycling, or and that mechanical recycling should really come on top of chemical recycling under all conditions, and if this argument refers to all technologies, or is based on current knowledge that might change or evolve in the future. That's my first question. The second is the recycling definition. I'm sure if we bring like 5 academics here in the room, they might not agree on this. This is super complex. What can be really considered recycling or circular economy? That we can have a debate around this. At least in Europe, we are a little bit more advanced compared to other regions, because if you look, for example, in the United States, now the discussion of what should fall into recycling rate has started very recently. At least we're a little bit more advanced in this regard. But I was wondering, with a view to the revision in the future at some point of the Waste Framework Directive, and that's something I can come back and can give insights later, whether maybe there is a need to rethink the whole waste hierarchy and the whole structure or the different layers, rather than trying to strictly add this process in one of the existing, let's say, layers that we have in the waste hierarchy, especially since the research field of circular economy is growing rapidly with more evidence coming in and more knowledge. So I was wondering if you have any views on this. Yeah. Okay.
Well, as I said, maybe first of all, we need to understand where we are, and we are in a situation where we have a lot of plastic which is not recyclable. And it's not recyclable, not just because it's not recyclable, but it's also because there is no infrastructure and there is no maybe market value for that. So a lot of it ends up simply burnt for that particular reasons. And then there is also quite a bit of plastic which is simply not recyclable, and it's even what we know is from some of those technologies, they are also unable to treat those plastics. So these are so-called hard to recycle plastics, and they are also mixed plastics. So there's a lot of there is quite a bit of evidence that even those technologies, they are not unable to treat, or if they are able to treat, they have a lot of losses in the process. Meaning that they would not ever donate back to plastics. They might maybe donate into something else, or simply lose a lot of it in the process. So the question is, do we want to keep those hard to recycle plastics in the market in order to try to recover a little bit of plastics from them, or mostly maybe donate into fuels and some other chemical substances? So I think the focus has to be on the innovation upstream and not downstream here. So I think there is we really need to move towards innovating upstream and phase out some of those items that are very hard to recycle. So design has to be for mechanical recycling. As I said, also it will benefit chemical recycling and chemical recovery, because the fact that if you design a product to be mechanically recycled, it will also help you to deal it when it becomes too degraded, and that's where chemical recycling could play a role. There is also, I think, as I said, quite a number of recent studies, including from European Environment Agency, still conclude that there's a lot of lack of knowledge. So it's hard also to comment on some of the impacts of some of the technologies. We have been trying to follow and comment those as much as we can. We are also limited in our capacity. I might have lost your second question, so maybe if you or the third one even. Yeah. So if you can just quickly repeat it.
Just a quick reaction on the waste hierarchy, including the Waste Framework Directive, and how do you see it in the future? Whether we should try to fit existing process in the current structure, or why not even rethink the whole hierarchy, let's say, as a whole?
Yeah. Actually, in fact, we do recommend redesigning changing, modifying the waste hierarchy, because it doesn't really play its role. It's too much focused on waste, and it should more focus on the product. And then it's also an opportunity to legislate those new technologies and put them in the right order. We recommend having still mechanical recycling as the first option, or physical recycling if you like, and then having chemical recycling and recovery options as a second. And I think it makes a lot of sense when you look at the impacts that they have.
Okay. Thank you very much, Yannick. There will be opportunity to come back later in the discussion. So I will now turn to Sylvia Ale, Deputy Head of Unit at the European Commission. And Sylvia, first of all, thank you for patiently waiting to have your turn. And I know there has been a lot of information and inputs. I hope some of it is useful for your ongoing processes, and at least you know now who to ask for if you need more detailed information and data on some of these issues. So yeah, I mean, any reactions, thoughts from your side? I know you have a very heavy portfolio, and chemical recycling is a very heavy topic itself. So yeah, what are your thoughts based on what you heard today?
Yes, well, thank you very much, and good afternoon to everybody. Can you confirm you hear me well?
Perfect.
Excellent, very good. Yes, so well, I mean, thanks a lot for inviting also the Commission to this discussion. Because indeed, I mean, we're following very closely this topic because we are very often faced with many of the questions that you have raised today, what the different speakers have raised, and we also have questions back to them. So I think it's a discussion of several years now, and I believe that it is not going to stop very soon. But I mean, as you know, as the previous speakers have already recalled, that I mean, the EU has a very serious decarbonization agenda, which is, I mean, at the center of the European Green Deal, and so there are many strands of policy and lawmaking happening right now in order to realize that, and of course. The primary source for our agenda setting is in the Circular Economy Action Plan and the European plastic strategy, which you know has identified these circularity challenges in the plastic value chain. So that is not contested, and so it is great to see that indeed there is a lot of cooperation happening on the ground between the different actors. In the value chain, and so I mean the chemical recycling question is very relevant. I think we can recognize that also from the Commission side, because it is it should be part of the solution to the challenges that we're trying to address. I mean, so, and we have already we have taken several legal measures in the past years to improve this. You know, starting with the new revised, more ambitious recycling targets. We have also we're now also on the path of developing mandatory recycled content rules to ensure that there is indeed that regulatory measure that pushes the use of these secondary raw materials. There is a lot of changes that are happening in relation to improving separate collection in the context of redefined waste legislation, and also on the redefined extended producer responsibility roles, and of course, among the latest actions is the new single-use plastics directive, which is essentially the first act where we are supposed to define more detailed rules on the calculating the recycled content in new products. So following, I mean, we have also of course revised rules on how we calculate recycling. So there is there is some changes that have happened, but it also require further reflections and further implementing rules. So these discussions on chemical recycling are clearly part of those discussions. There are also other new policy developments that I mean several of the speakers referred to, which is more in terms of upstream measures. Which also in a way will impact what is the role of chemical recycling, and that is indeed trying to define through the sustainable product policy and its different legal instruments to improve the design of products so that they are easily recyclable, and that primarily concerns packaging, which is one of the biggest uses applications for the plastic. So a lot of measures should, a lot of effort should go at the upstream. Which will have impact on the separate collection of waste, on sorting of waste, and ultimately in the choice of recycling technologies applied. So we recognize that there is still a lot of innovation happening, both in terms of sorting, mechanical recycling, and also chemical recycling. And from the Commission's point of view, we are supporting all of these changes. I mean, we have several R&D funding opportunities that we offer, and based on the information that we receive from the stakeholders, it is clear that there is a lot of innovation in the pipeline, and it is it's clear that legal certainty is key to such developments. So for all developments, not just the chemical recycling. So to the extent that reprocessing operations meet the current definition of recycling, they already under existing rules can contribute to the recycling objectives. And I mean, it is, for chemical recycling and some other operations which involve a mix of different mechanical or physical or chemical recycling or recovery operations, or and especially where they have a mix of different outputs that are used as products or as fuels. Also, we have existing rules that call for the application of the mass balance approach to try to account to account only for recycling targets the waste materials that are actually subject to recycling. So this is a principle that is established in the law. I mean, it is not defined in detail, so it's more at the principle level, at the principle level, and so we do understand based on the different interactions that we've had that. It is not very obvious how to operationalize that for the different processes, and also to ensure that this is done in a harmonized way across the processes or the different operators. So from the Commission's standpoint, I mean, we are of course very closely monitoring the different studies and researches that are happening. We're actively engaging with the stakeholders on this topic. So we have several work strands that look at the chemical recycling in particular. So we have we're currently developing rules on how to measure recycled content in plastic beverage bottles. There is clearly a need to also account in these rules for the process that are the chemical recycling processes. There is our joint research center is also engaged in assessing the different waste management processes for managing plastic waste. So ranging from of course chemical recycling to mechanical recycling and other treatments, including disposal. And we are also recently started another study with the Joint Research Center to look at how we could fine-tune the calculation rules for recycling to take into account these different processes and different outputs to try to clarify this principle of mass balance. So there is some reflections happening in the Commission, along these different work streams, and these are just a few of them. That there are others. Such as on the what our colleagues in DG Sante are doing in relation to authorization processes for food contact material from recycled plastic, and so all these discussions that and the research that is done by the industry is something that we're also very interested, and so I'm very thankful for you to have invited me to follow a discussion to at the end of the day that we can find a balanced way how we can achieve the objectives of decarbonization and the circularity for our economy and the plastics value chain. So thank you very much.
Thank you, Sylvia. As I said earlier, I hope that this will at least point out to you the people that you need to ask for more specific information later. I don't know if on the mass balance discussion, if you want to share with us, or if you maybe this can also be done bilaterally, if there are any specific gaps that you see that are really in need of being filled in the coming future. Because of course, some of these chemical recycling processes, they produce a mixture of different products. And at least from what I've seen in the literature, sometimes it's not very easy to calculate the specific sales of all of these different outputs. That's something we can get inputs later from Christian and Chloe. That's one of the points. If you see any specific gaps that need to be filled in the future, then one other interesting point raised in the literature refers to the different collection schemes at the regional and local level. I guess you know very well that the collection is very different across Europe, and even is often adapted to different local contexts. I'm talking about collection of plastics, and that's very much linked to the chemical recycling of plastic recycling discussion, because for many of these different types of plastics, from what I understand from the discussion today, there are different options. So all of this, I was wondering if this variety of different collection schemes can pose some risks, let's say, to have some consistent approaches across the EU on chemical recycling and plastic recycling in general, and if this is something that is being taken into account at the Commission level. Of course, I know that some of the things are beyond your hands, but I was just wondering if you have any thoughts on this.
Yeah, thank you very much. No. I mean, my colleagues are actively working on the defining rules on how to approach how to implement this mass balance approach, where to put the limits to it, because I mean it's clear that we cannot account for every gram and kilogram of waste and trace it back to the exact amount that ends up in the different products. So it's I mean the exact math is not going to be possible for these various processes and various that subsequent processes and the variety of different products. So what we're looking is for a model that gives enough legal certainty that the definitions of recycling are respected, and that there is a clear also traceability for the accounting through the different process. So this is so this is what our colleagues are working, and there was I mean, this is in particular in the context of defining the recycled content calculation rules for single-use beverage bottles. There have been several stakeholder events. I think last one was at the end of April, and this work is still continuing. So of course, the stakeholders will continue to be consulted on this as we try to find some common ground, and we are ready to come up with proposals, which should be in autumn of this year. So indeed, it's you know, the credibility and the transparency in the process which we're looking at. So in relation to your other point on the separate collection, so indeed, I mean, it is. I mean, the separate collection is the beginning of the process where we can. By having you know, an effective process that is able to facilitate the implementation of the waste hierarchy is what we're looking at, and indeed not all separate collection models are geared towards it. And as what Janek was mentioning before me is that, I mean, when we look at separate collection, it's you know, primarily we need to see how we can achieve separate collection for reuse of products. So this is, you know, in particular, I mean, on textiles, which is the latest separate collection obligation that's introduced under EU legislation. So for separate collection, we have also embarked on an exercise in the Commission to see how we can fine-tune the rules or the guidance to the member states on how to improve the separate collection that would really deliver quality quality in terms of preparation for reuse and recycling of materials, and see if we can develop some rules geared towards improving either the from the logistical point of view, or in the or downstream for sorting. So and then for this as well, we have engaged now with all our stakeholders, and there are a number of workshops that are going to happen in autumn and winter. But as it was mentioned already before me, but also I saw in some of the commentary there, is that we need to focus on innovation upstream, you know, so designing products for recyclability and for reuse, as well as innovating in terms of how we can separate sort products or packaging. So these are all in developments that will have an impact on the cost efficiency of mechanical recycling, but also in terms of chemical recycling. And just on the to also provide a little feedback on your questions on the waste hierarchy. I think again, I think the waste hierarchy as it is fit for purpose, but we are open to look at how we can you know, provide more legal certainty in terms of the different operations. So that is why we have just past month launched this reflection process with the Joint Research Service Center to see if there's any way how we could fine-tune our rules or definitions to provide more legal certainty to these different processes and calculation rules for measuring recycling.
Okay, good. Thank you, Sylvia. So maybe I can ask now all panelists to maybe turn on your camera for the last 10 minutes of the discussion. Okay, thank you for your time. As always, 2 hours is not enough. We could be speaking for much longer, but I would like to at least give you the opportunity to come back once and comment on any of the points raised. I have also some specific questions for you. I don't know if we can answer all of them now, but maybe I start with Matthew. Matthew, probably that there is this discussion on textiles in Europe. There will be a textile strategy coming out later this year, and some of the studies or scientific studies, they're looking at the possibilities of deploying the chemical depolymerization technology for both PET packaging and polyester clothing fibers. And I was wondering if this is something you've looked into your research, and whether you think we are at some point there could be such combined approaches in the market. I think that's very interesting for policy discussions as well. And why I let you prepare to raise your points on this or any other topic you would like to. For Chloe and Christian, I guess there was this discussion on mass balance, and some of the participants raised the question of whether we can actually trace all of the different outputs of the mixture of different products that come out of pyrolysis process. So I was wondering, from an industry point of view, if you feel confident that you have this evidence and you can feed in current processes that they are in place at the Commission, or whether there are any, there is some areas where more research is being needed or more evidence needed. I don't know if you have any thoughts on it. And if you have any thoughts also as well on the waste hierarchy and the different kind of steps and where chemical recycle or whether parts of chemical recycle fit into. Yannick, I mean, there was a specific question in the panel by Karina Oliveira, why mechanical recycling should always come earlier than chemical recycling. Maybe there is an advantage that perhaps you haven't looked into your research. I don't know if you have thoughts to share on this. You already touched upon this earlier. And I was wondering as well, Zero Waste Europe publishes a lot of information, collects a lot of data. I was wondering, is there any specific area where you really see a big need now? We need data on this in the very short term. A big gap that you're seeing, because we have quite a few academics as well in the panel. So I'm sure maybe somebody can pick up your points. Sylvia, I will let you, in the end, have any last remarks or anything that you would like to bring to the discussion. I would like to ask all of you to do this maybe in 2 minutes. I know it's very challenging, but there will be opportunity to have further discussions on this from September onwards. So Matthew, can I start with you?
Okay, thanks. And textiles is a really, really interesting beast in itself. And I do think that chemical recycling could have a lot to offer in that area. And I think the advantage that maybe chemical recycling might have in there is that we've heard that part of the issue with recycling of plastics is the separation and getting stuff in the right sort of stream. But I think with textiles, then the separation of them might be a bit simpler to do. And I think that the advantage that chemical recycling, from my sort of simple chemistry mind, actually has is the catalyst in the process. It doesn't care where the carbon comes from. All a catalyst really cares about is how the carbon atoms and the oxygen atoms are bonded together. It doesn't care if it comes from a Coca-Cola or a Pepsi bottle or your granny's carpet. It's all exactly the same. So I think the systems that are being touted as potential routes for polyesters and polyamide depolymerizations should also work for textiles as well. I can't see any reason why that wouldn't work, and I think it could have an advantage here because of the fact that you might have purer streams for those markets. So yeah.
Thank you, Matthew. Thank you for your time. Christian, any thoughts on mass balance, waste hierarchy, or any other points you would like to pick up from this wealth of points raised today in arguments?
Mass balance must be traceable, yeah, let's say, and therefore we have certification, yeah, and it's already done by the industry that they certify really every value chain step in the chain, yeah, where every year an auditor comes to every site and audits the bill of materials of a company. So it's already done. So it's not an issue. Yeah. What, to my opinion, is more an issue is when I think on such suggestions like polymer to polymer. That sounds nice, yeah, but it is not. It is not thought through, to my opinion, because many of the chemical companies, they're not only producing in the one plant only a polymer, they're also producing chemicals. Yeah. So I would love to have really both, yeah, and to take in this waste. And also, I would not love to have only a regulated market where I have high price recyclates regulated from the member states, yeah. But I would like to have also a voluntary market which would really encourage consumers to buy green products, yeah. And therefore, very high prices of recycled plastics would deteriorate the voluntary market. And therefore, we need clever mass balance rules to allow really to serve not only the regulatory-driven market, but also the voluntary markets in an economic feasible way. And this is, and if there are some legal aspects also in that, especially it has to comply with the Waste Framework Directive for sure. Yeah, that's also clear. But if something is maybe not clear enough, then we have to think about to change that. Yeah, to change that and to think about some rules. Yeah, that really we can drive really on the regulatory side this polymer to polymer and polymer waste to chemicals in the voluntary market, that we can address the switch to the circular economy.
Perfect. Thank you, Christian. Chloe, any thoughts, remarks?
Yeah, I'm just going to add a few more elements on the mass balance side. Usually there is a confusion, I feel, between mass balance that is often talked at the pyrolysis level. So at the pyrolysis level, we have a physical mass balance, which is actually very straightforward, and we can very easily identify what goes toward recovery, for instance, and what goes toward what is being used as a feedstock or final product. And in that sense, in the, for instance, definition or calculation of recycling rates, it is very clear that those, items going towards recovery obviously should be discounted as aligned with the Waste Framework Directive definition. Then there is obviously the other step that Christian explained at the chemical site, where again here obviously traceability should happen, and on our side, Plastic Energy, we have the ISCC Plus certification and RSB, for instance, which are two of the widely recognized certification schemes. So I think it is worth pointing that out. When it comes to where chemical recycling fits in the waste hierarchy, so here I think that there is a confusion between when people talk about chemical recycling and chemical recycling technologies. So chemical recycling technologies can be used for many different purposes. The definition of chemical recycling does exclude fuels. So in that sense, the use of fuel in the waste hierarchy is and falls under energy recovery, and the use as feedstock final products. Or anything aligned with the definition of recycling is under recycling. And I want to insist on the fact that it is under recycling at the same level as mechanical recycling. It is a recycling process that basically just targets different polymers and different types of plastic packaging or other items that mechanical recycling cannot recycle. So in that sense, it is just another recycling method.
Thank you, Chloe. Yannick, I don't know, if you have any, you can also use your 2-3 minutes, just react on what Christian, Chloe has mentioned, or any other point. I have, I wish we had more time, but we don't.
Yeah. Well, thank you. Well, I think some sort of prioritization among the technologies is really a must. We can't consider all the processes at the same level because they have a very different impacts, very different outputs, and so simply they are not comparable. When it comes to issues that we would like to have more information, we start seeing some data on in terms of the climate impacts. I think it was driven by the fact that the taxonomy included the requirement for these processes to be comparable with the virgin plastic. Yeah, but we see almost nothing on in terms of residues and the toxicity. And finally, I think when it comes to I feel the most of the discussion is when it comes to chemical recycling is around petrochemicals. I see there's a huge interest in continued use petrochemicals as the only option, really. And I think this is regrettable because there are other technologies in there which can produce polymers and as an output which should be prioritized and equally. But we don't see much discussion on that. So yeah.
Okay. Thank you, Yannick. Sylvia, would you like to any closing remarks from your side? As I said, it was a heavy day.
Indeed. Well, I will leave the closing remarks to you as the organizers, but I would just like to point out, something that was maybe not addressed too much today was really the objective to try to achieve higher quality outputs. I mean, I think that is something that we are also having in mind and having this reflection ongoing on how we can improve that. So indeed, the current legislation does not focus on the quality of the outputs. I mean, it is just any recycling that produces a product which is not fuel is considered as recycling. But in order to maintain these products in the economy for as long as possible and to really aim for the high value applications, the question is how we can fine-tune the rules for that. But I mean, this is something that requires a reflection at the primary legislation level. And so for this as well, I mean, we are very interested to hear the views of all the stakeholders today, and also listening in. So. Thank you.
When you mention primary legislation level, which one specifically you refer to?
The primary legislation is either the Waste Framework Directive that defines what is recycling, or any other of our legislation that actually defines the recycling targets. When we define recycling, mandatory recycled content targets in new products, that is an element of quality already. But can we drive high quality recycling without necessarily setting these mandatory recycled content rules? So that is the reflection that we have now commenced with our colleagues in the Joint Research Center to see how we can really reflect the quality aspect in the different processes or accounting. But I mean, this is not something that would result in an instant rule. Clarification in the rules themselves, because you can't change the rules unless you change the primary legislation on this. So this was something that was also discussed in the latest stakeholder events that we had a couple of weeks ago. So this is just something I would like to point out because we're interested to also hear reflections from the stakeholders on this.
Okay, good. Thank you, Sylvia. And I take here as an important point, there will be a lot of discussions in the coming year and looking into the 2023, I guess, with a new revision of the Waste Framework Directive. Very interesting discussion. Apologies for taking a little bit longer of your time. I hope it doesn't disturb your program for today. I would like to thank all of you, our speakers, for taking the time to be with us. I hope you found it as useful as I did. I hope we'll have the opportunity to continue this discussion in the future. We'll have some plans for further events from September onwards. I would also like to thank all participants for staying with us for almost 2 hours today. And there was heavy discussion, but the video will be made available later on YouTube. So if you want to come back to some of the points, you feel free to do so. This was the last public event from the Energy Resource and Climate Change team of SEPS before the summer break. And as I said, I can see already we will have a very busy autumn. So thank you, all of you. I wish you a good day and a very pleasant summer break. Thank you.
Thank you.
Yeah, thank you.
Bye-bye.
Thanks.